Welcome back, everybody. Hope everybody's having a good day, and hopefully today's going to be pretty easy for you guys as well. Um, as I have been saying for the past couple weeks, you're probably going to need graph paper, and today's probably the first day where you are actually going to need that graph paper. If you don't have graph paper available, it's really quick to just go online and search for digital graph paper. You can print out PDFs of it, but as a reminder, you can get graph paper in the school as well. So if you go up to the school, there's a box of seventh grade stuff. There are rulers and graph paper there that you are welcome to use. I'm not going to be graphing our solutions, maybe a sketch, but that's about it for today. But at this point, I feel like you guys have a pretty good understanding of what X and Y axis and graphing coordinate points will look like. But if you do feel like you're having trouble with that, just let me know. There's a couple of problems on Khan Academy that I'm going to recommend to go along with this. But what we're going to be doing in this virtual lesson is going to be in lesson 12 from your book. So lesson 12 opens up with this exercise about Emily, who scored 32 points in a basketball game. So we're trying to write all the possible ways that she could have scored 32 points with only 2 and 3 point baskets. So now not counting the free throw shots. So let's think about this for a little bit. She can't make just one three-pointer, because if she makes a three-pointer, that'll give her 3 points. She ends with an even number. So if she only makes 2-pointers after that, then that means that she would end with an odd number total. For example, if she scored a 3-pointer and 2 2-pointers, that would give her 7 points. But she ends with an even amount. What we could say is she has 0 3-point shots. Maybe she didn't like to do 3-point shots. If she did 0 3-point shots and her total was 32 points, well, that means that she scored 16 2-pointers. Now, we said that 1 3-pointer couldn't count, but let's think about 2. 2 3-pointers is 6 points. If she scored 6 points, she needs to score 26 more points to earn 32 total. Well, if we take 26 and we split it into 2 pieces, or 2 points, then that's going to be 13 2-pointers. What we should start seeing is that there is a pattern in this table. For every 2 3-pointers that she makes, her 2-pointers get reduced by 3. So 3 points, 4 3-pointers for 12 points. She needs to make 20 more points to earn that, which is 10 2-pointers. And we can kind of continue this pattern here, 6, 8, and 10. But we can't go any further than 10, because if she makes 12 3-pointers, she's going to be over the 32-point amount. And what you'll also see is that if we get 10 and keep on subtracting 7 each time, subtracting 3 each time, we can't subtract 3 from 1. She can't have negative 2-point shots. So we can actually come up with an equation for a table like this. Say that this is our x value, and typically the one on the left side is our x and the one on the right is our y. Then we can say 2 points for every 2-point shot and 3 points for every 3-point shot is equal to 32 points total. And now what you should see is that if we substitute any of these x and y values into this equation here, it's going to be true. For example, 2 times 16 is 32, plus 3 times 0, which is 0. 32 plus 0 is 32. And we can test it with any of these values here. We'll do one more just to be sure. Let's do 4 and 8. So 2 times 4 plus 3 times 8 equals 32. Well, 2 times 4 is 8. 3 times 8 is 24. And it is true that 32 equals 32. So that's what we're going to be doing today. We're going to be looking at equations and using a table to figure out the values that actually make it true. Now, the next step to this would be then graphing this equation. Now, I want you to think about this, and I will actually sketch the graph for this. It's not going to be exact, but it'll be pretty good. We've got our x and we've got our y. And let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll do 10 for our x. And 1, 2, 3, 4, 5, 6, 7, 8, 9 for our y. So if we go, let's see, 1, 2, 3, 4, and 8, we'll have something that's right about there. 7 and 6. And you'll start seeing that there's a linear pattern that's going on here. It's going to make a straight line. All of the examples that we're looking at today are going to be some sort of linear pair where there's an x and a y value that make a straight line. Now, I actually made a mistake here, though, because I shouldn't have actually connected the dots. I should have left the dots as they are. The reason why is because you can't make half a shot. You can't say that she made 7.5 2-pointers or 4.5 3-pointers. So this actually should be just dots, not the line itself. So be careful when you're looking at the context of your problem. Sometimes you are going to have the line connected, where you can have halves and quarters and everything else. Other times you're only going to be using whole numbers. And when you're using just whole numbers, you're just going to include the dots there. So I wanted to talk about one example in particular. These are all ones that you can be trying. Exercises 1, 2, 3. 4 is the one that I actually wanted to talk about with you, though. So for number 4, it says that we have the equation 2/5 x plus y equals 11. And the first question says, will you choose to fix x or y? When it says fix, what it means is pick values for either your x or your y. What do you guys think? Should we pick a value for x or should we pick values for y? To me, I think that picking values for x makes a little bit more sense because y could be anything, x could be anything, but it's a lot easier to find 2/5 of multiples of 5 than to find 2/5 of any random number. So that actually gets us into part B, which says, are there specific numbers that would make your computational work easier? And like I just said, multiples of 5 are going to make this really easy. So on the next page, it actually has us fill out a table, just like the table that we did in the opening exercise, except for that this one actually has your linear equation in the table itself. So I'm going to go back to our screen over here. And now that we're working with this equation here, we said that there are going to be x and y values. I'm actually just going to use 2 columns here. You're welcome to use the 3 column where you're showing your work in the middle, but for the sake of time, we're going to say that this is our x and our y. And I said that if we pick multiples of 5, this is going to be really easy to find our y values. So 15, 20, and let's stop there because 1, 2, 3, 4, 5. I think they only have 5 rows. 1, 2, 3, 4, 5. Yep. So here's the really easy one. When x is 0, we've got 2/5 times 0. That's 0 plus 11. So y would have to equal 11 there. When x is 5, well, 2/5 of 5 is 2. And 2 plus something has to equal 11. That something in this case is going to be 9. We'll do one more and see if we can see any sort of pattern here. 2/5 of 10 is 4. 4 plus 7 equals 11. Therefore, y has to be 7. What we should be noticing here is that for every 5 that we go up on our x values, our y values are actually decreasing by 2, which would mean that this is going to be 5 and that this is going to be 3. Now, once again, we can graph these values. If you think about this as a table, these are coordinate points: 0, 11, 5, 9, 10, 7, 15, 3, 15, 5, 23. I want you guys to think about this problem. Everything that we came up with here is whole numbers. But could we have a fraction answer? Obviously, we could find values in between 0 and 5, but it is going to be a lot more complicated. For example, if we wanted to find the value 1, 2/5 times 1 is 2/5. In order to add something to 2/5 to get to 11, we would have to add 10 and 3/5, which, as you notice, there is a fraction in our problem here. So In this case, we're not going to have a dotted line like our first example. We're going to have a connected line because it could be 0, 1, 2, 3, 4, any value for our x and any value for our y. So that's the difference between the dotted function, which was, like I said, I made a mistake on that graph there, or a line function where you're actually connecting those lines. What I'm going to ask you guys to do, now that you've seen this video and you've seen a couple examples, is I want you to look specifically at the problem set for lesson 12. There's one example where you are filling in a table, and there's other examples where it just gives you the equation, and it doesn't say that you have to use a table, but it might help you out. But it does want you to plot the solutions on a coordinate plane. So that's why I keep on saying you might need graph paper at this point. We are going to do more and more with graphing. So I would recommend either go to the school and get some of that graph paper, or download the PDF and print it out that way. Even if you could get it on a tablet where you can draw on the tablet, do something that way as well. A lot of options for you. If you're really having trouble getting the graph paper, let me know. I might be able to come up with something for you. But practice with this. Let me know how it goes. And keep an eye on Khan Academy as well, because there's going to be a few examples that are like this, including videos and lessons that should help you out with this as well. Have a good one, guys, and we will see you next time.